Hi everybody, I wanted to tell you a little bit about the standard normal distribution. This is from section 5.4. So the standard normal distribution, as you can see here in this picture, it is unimodal, meaning only one peak, and it's symmetric. You can see right down the middle there's a dashed line. And the left side of this distribution is exactly the same as the right side. We use this distribution to help us find probabilities. What goes across the horizontal axis is what's called a z-score. And a z-score is the number of standard deviations you are away from the mean. Let me do a couple of examples. I'm looking at the negative z-score table, but there's also a positive z-score table, which I will look at in another video. Please notice something in this picture, that the area is always to the left. Area to the left. Think of these z-scores as boundaries. They are separating that blue area right there from the rest of the white area in this graph. A certain z-score is separating those two areas. So if I wanted to find the probability that a z-score randomly selected from the standard normal distribution is less than negative 1.35. So z-score is less than negative 1.35. Our table reads to the left. You can think of less than to the left, greater than to the right. So the way we use this table is just to make it more compact. They designed the table so that it's only one page for all the negative z-scores. We want to look at negative 1.3 and look down the first column. That's bold. I'm going to move the ruler here so you can see that's at negative 1.3. And then I want to look at the hundredths place. That's going to be that first row across the very top. It's going to tell me what column to use. And that's 0.05. So that's 5 hundredths in that number, negative 1.35. So 5 hundredths, 0.05 is right there. If I look at that row and that column, you can see there's my answer. It is 0.0, sorry, my pens give me some trouble here, 885. Or we can call it 8.85%. Generally, your homework will probably ask you for a decimal, but because it's a probability, it can be shown as a decimal or as a percentage. We keep all the digits, by the way, of this decimal value. Don't round these. So 0.0885 would be our answer here. If you're looking for probabilities greater than, we have to think about that the whole area under the curve here at the top, the entire area, the total area is equal to 1. So total area, you could think of it as 1 or 100%. I like to think of it as 1 because our decimals here in the middle of this table are not percentages, they're decimals. So if I wanted to find the area or the probability that the z-score is greater than negative 1.35, let me do that on this left side. I would look on the other side. But the thing is, our table only reads to the left, as we've said. So to find the area of a certain z-score that's greater than, really what I'm looking for is the area here in white in this picture, in this curve. So I would take 1 minus the area to the left, which is 1 minus 0.0885, because I just found the area to the left. And let me get my calculator. 1 minus 0.0885 is 0.9115. So the area to the left of that z-score, negative 1.35, which would be, think of it, the area in blue in this little picture, is 0.0885. The area to the right, or the z-score, the area, the probability that the z-score is greater than negative 1.35 would be 0.9115.